Hi, it's Mr. Anderson, and today I'm
wrong
going to be
here,
talking about
everyone?
series
Okay,
and
you
parallel
what?
circuits.
Good one?
These
What
are a
happened all
couple
over
of
the place?
different circuit
I thought
diagrams. Remember, this stands for a
you're
battery,
right
and each of
there.
those stand
You
for a
mean
resistor.
this is a
And so this would be a
capacitor me.
series circuit,
That's a
meaning it's a
lover
closed
place you're
circuit, so there's a
quoted.
loop where
You're
electricity can flow the whole way
quoted.
around.
You not
And then we have
my
three
own. You're
and so the
not
electricity that
getting
goes through
young,
this
huh?
has to
You
go
are
through
having
these
a
as well.
lot.
If you look at this
Stupid
one, this is
alien,
one
do a
battery
lifetime
connected to
here
three
alone.
resistors as
I
well,
what
but
the
they're
hell?
parallel
No,
to
you
one another.
don't.
In other words, there's
How could
three
I?
loops that electricity can take, and so
Looking
we call it a
like who
parallel
were?
circuit.
I heard
Now,
him looking Jack
the
your
first time you look at a series and a
What
parallel
the hell
circuit when
did
it's
I
actually
wrong?
connected,
No,
there's some
what?
stuff that's not super
Wrong.
intuitive. In other words, there's some
No,
weird stuff
don't
that takes
alone
place.
here.
But once you really understand what's going on in
Okay,
both a series
just
and
go
a
to the
parallel
path
circuit,
forward
you'll
this.
do much better.
What
And
is the ring?
so
What
today I
hell
want to
is
show
going
you
on? You don't
basically
just feel
a
like
parallel and
no,
a series circuit,
you're
a few
alone.
demonstrations, and I'm going to be using the circuit construction kit. This is at
Adios.
phet.colorado.edu,
We
and
got
I would encourage you to go there, play around with it. It's the best way to learn about electricity is to actually play around with it. Okay, so right here we've got two different loops. This one is so this would be a battery right here. It's a 9-volt battery. This is an ammeter, which is going to measure the amps. We've then got wires connected to a light bulb, back to a switch, and then back to the battery again. And so this would be a series circuit, because electricity is going to flow in this direction through the battery and then back, through the bulb and then back again. And so when I turn it on, we can see that electrons are flowing. We've got 0.9 amps, and then it's running through a light bulb. And so these rays around the outside of the light bulb show you how much light is being given off from that. And so the first thing I'd like to do, let me turn that off for just a second, so let me open that circuit for a second, is kind of get a sense for how much electricity is coming out, or how much current is flowing through there, and how much light are we getting off of that. And now I'm going to add another light bulb, and I'm going to put it in series. So let me add another light bulb here, and I have to break this split junction. And let me connect both sides of that. Okay, so now we've got two light bulbs. We've got the same battery. You kind of remember how much light we were getting at it before, and you remember the speed. And so let's turn this one on now. Okay, so in a series circuit, what we have now is those two bulbs are not as bright. And the reason why, and if you remember how much speed we were getting, how much current we were getting, remember it was 0.9 amps. And so in a series circuit, if we add more resistance, we're going to decrease the amount of current. And as a result, we're going to have dimmer light bulbs. And so the current is going to be the same through every component in a series circuit. And so the other thing about a series circuit is, let me remove this. So let me split the junction. Okay, so when I split the junction there, I cut that wire, and so it wasn't connected anymore, and so both bulbs went out. And so the two things that you should learn, number one, is that in a series circuit, all of them have to be working for current to flow. And the second thing is that they all have the same amount of current. Volts is another thing, and so let's add a voltmeter as well. So if we add a voltmeter, this is a 9-volt battery. If I look on either side of the light bulb, we'll find that the volts are 9 volts. If I move this lead over here, this electrode over here, we find that it's 4.5 volts. And then if I shift both of them to this side of that light bulb, it's 4.5 as well. And so the sum of the volt, or the voltage drop between the two components in that, are going to equal the volts that we have for the whole thing. So it's 9 volts, but then each of those bulbs, it's going to be a drop of 4.5 volts. So we have 9 volts, and then we have 0 volts when we get to the other side. So let's get rid of that voltmeter, and let me turn this one off. And so let's return that for a second. So get a sense of how much light we're getting from these two light bulbs. And we have 0.45 amps. And now we're going to look down here at a parallel circuit. And so a parallel circuit, there are two parallel pathways. In other words, there's a wire that goes through this bulb and a wire that goes through this bulb. And so when I turn this on, there's a clear difference between the two. And the first time I saw this, it was totally confusing to me. In other words, these two light bulbs are as bright as that one light bulb was before, when it wasn't in series. And so the first thing that should stand out to you is that these two bulbs are as bright as that one bulb when it was before it was hooked up in series. And so another thing that's happening is that we actually have way more amps moving through this, and so you can see that the electrons are moving more quickly. And so the difference between a series circuit and a parallel circuit is that the current is actually increased. Remember when we had, let's go back and remove this and just connect it together. So remember here we had 0.9 amps for one light bulb, but here we now have 1.8 amps. In other words, the electricity is actually flowing faster. Why is that? Well, here there is the current of this thread and there's the current of this branch, and the two currents together are going to sum up to this current. And so before, when we were saying the voltage drop in each of those sums up to the voltage of the battery, well, in a parallel circuit, those two pathways, in other words, those two currents, are going to sum up to the current of the whole branch. Another thing that happens in a parallel circuit, let's kind of remove this light bulb. And so remember when I removed a series light bulb, the whole thing went out. But in a parallel circuit, when I remove one of those light bulbs, the other one keeps moving. Now you should have seen that when I removed that light bulb, the amps dropped down to 0.9, but electricity isn't flowing through this side. But by hooking it up this way, we've now got electricity, or path for electricity to go. When I was a kid, I remember we had a string of light bulbs that were hooked up in series, and it was the most annoying light bulb strand that you could have for Christmas lights. Because if you ever had one bulb go out on a series circuit, then the whole thing was broken all the way down. So you had to search through that string of lights until you found the one that was burnt out. Now they use parallel circuits, and the reason they do that is you don't get that drop in current with each bulb. And the other thing is that you can have a break in one of the bulbs, and the other ones are all good. And so that's kind of an introduction to series and parallel circuits. Remember, in a series circuit, the current is going to be the same through every part of that loop. But in a parallel circuit, it's going to be the sum of the two will be the sum of the current through the whole of the circuit. And the voltage drop, if we add our voltmeter, in a parallel circuit, it's going to be the same along each thread. So remember, this would be a 9 volt on this pathway, but it's also going to be a 9 volt on this pathway. And so you're not getting anything for free with a parallel circuit. You're actually going to go through more energy using this setup than you would over here, because you're actually grabbing more amps. So that's parallel and that's series circuit, and I hope that's helpful.